Assalamu alaikum and very good day. My name is Dr. Javed Iqbal. I am here with another video on fewshot learning. The title of this video is Approaches of Fewshot Learning. In my previous video, I have given you an introduction of what is fewshot learning. Before watching this video, please watch my first video on fewshot learning. Fewshot learning FSL is a branch of supervised learning focused on learning from limited or few number of training examples. Actually, we use fewshot learning in scenarios where we have limited or very small amount of training examples. Fewshot learning is best suited for those type of problems. Fewshot learning is an example of meta learning. Fewshot learning is most suited when learning for rare case when obtaining label data is hard or impossible, or we can use fewshot learning when we want to reduce data gathering effort and computational cost. So these are two possible scenarios of using fewshot learning. First one is when obtaining label data is hard or impossible, and next one is reducing data gathering effort and computational cost. This slide shows the working of fewshot learning. Fewshot learning is inspired from meta learning. Meta learning is learning to learn. As I have also shown this in my last video, that fewshot uses n way k, where n denotes the number of classes and k denote the number of examples or shots of each class. For example, in this diagram, we have a superset which comprises of n classes and k shot. Here there are three classes and each class has two shots. The query set has four images which can be used to classify the query set images into four different classes. One more thing that I want to mention here, that the data in query set may be different from the data in the sport set. This is the main theme of the meta learning. Meta learning learns the common representation of each class. For example, here is an example of fewshot classification task. Given the k equal 2 instances for each of the n3 classes in the sport set. We want to label the Q for dogs from the query set as Labrador, Saint Bernard, or Pug. Even if you never seen any pug, the beauty of meta learning algorithm is that even if you had never seen any pug, Saint Bernard, or Labrador, this would be pretty easy for you. We are going to need some meta learning. Actually, meta learning uses the metadata for learning. This slide shows different type of approaches to fewshot learning or meta learning. The first one is the prior knowledge about similarity. The second one is prior knowledge about learning. And the third one is the prior knowledge of data. These are the three popular approaches of fewshot or meta learning. First, we will discuss prior knowledge about similarity. In this technique, the similarity measure to differentiate different classes is used. Here, ML model try to learn embeddings in training tasks that tend to separate different classes even when they are unseen. The first type of approach is discriminating between two unseen classes. Under these approaches, there are two type of networks: Siamese networks and triplet networks. The next one is discriminating multiple unseen classes. Here we have three type of networks: matching networks, prototypical networks, and relation networks. In my next videos, I will share detail of these different types of networks. The second approach of fewshot or meta learning is prior knowledge about learning. Here, ML model use prior knowledge to constrain the learning algorithm to choose the parameters that generalize well from a few examples. Techniques used for hyper tuning in fewshot learning are mammal and reptile. These are two popular approaches in prior knowledge about learning. Next, learning update rules can also encourage good performance with small data sets. Here we will use LSTMs, long short-term memories, reinforcement learning, and optimization rules. Here are also sequence methods that take the entire dataset and test examples and predict the value of the test sample. Here we can use memory augmented neural network and SNL. The next approach of few shot learning or meta learning is prior knowledge of data. Here MN model exploits prior knowledge about the structure and availability of the data. Here the focus is about the structure and availability of the data, which enables constructing viable models from new examples. Two type of models here can be used. First one is the generator models. Generator models can be constructed for families of data classes. Here we can use pen stroke models or neural statistician. New examples for the training set can be synthesized. Here we can use analogies and end-to-end models. Analogies is well-known model from the Facebook AI search group. The few shot learning can be further divided into two levels. The first one is data level approach. Here, we should add more data if data is not sufficient to build a reliable model and avoid overfitting and underfitting. Approach focuses at data level. Many few shot learning problems are solved by using additional information from a large base dataset. The key feature of the base dataset is that it does not have classes that we have in our sports set for few short tasks. For example, if we want to classify a specific bird species, the base dataset can have images of many other birds. Here we generate more data using data augmentation or even generative adversarial networks GAN. So the focus of data level approach is to extend the data or augment the data. The next approach is parameter level approach. It's relatively easy to overfit on FSL samples as they have a high dimensional capacity to fit all data features. Thus, parameter space can be reduced by using regularization techniques or proper loss function to overcome this problem. The model will generalize on limited number of training samples. We can enhance model performance by directing it to vast parameter space using a standard optimization algorithm such as stochastic gradient descent SDG might not give reliable results because of the small amount of training data. Next, in parameter level, we train our model to find the best route in the parameter space to give optimal prediction results. Finally, this video gave you an overview of different type of approaches for few shot learning. I hope this will help you to learn the working of the few shot learning models. In my next video, I will give you more detail about the few shot learning approaches and data augmentation techniques. Thank you very much for watching this video. Please like, share and subscribe my channel. Thank you for watching.